Today we are reviewing probability. Our I can statements: I understand probability is the likelihood of an event occurring. I can find experimental and theoretical probability. I can use probability to make a prediction. And I can find the number of possible outcomes for a problem. So we're going to start by talking about experimental probability. Experimental probability is probability based on what actually happens. So we're going to go ahead and spin a spinner, and then we are going to record our results. And then we are going to calculate the probability for red occurring. Let's see. Yeah, experimental probability of spinning a red. Okay, so I'm going to go ahead and click my spinner. Okay, so I got a yellow. Just going to record my results here. All right, I got a red. I've got a green. I'm going to do this 10 times. Purple. Green. Blue. Red. Purple. Blue. And last one is yellow. All right, so when I want to find the experimental probability of spinning a red, I have to count up how many times I did whatever the experiment is. For this one, it was by spinner, and I did it 10 times. That's going to go on the bottom part of our fraction. So I'm going to go ahead and write it in fraction form down here. So the number on the bottom here is 10. I did it 10 times. Then I count up how many times I had red. I got red twice. So 2 out of 10 times. And then for our probability, we always want a fraction in simplest form. So we're going to divide 2 by 2 and 10 by 2. We're going to get 1/5. And then we always want, unless directions say otherwise, simplified fraction and a percent. So when I do 1 divided by 5 times 100, I get 20%. All right, let's go ahead and take a look at some more problems. So here, this is just another review. Experimental probability is an estimate of the probability of an event. It is called experimental because you make observations or experiments to find the number of times a certain event actually happened. So here's our formula. Experimental probability equals the number of times a certain event happened divided by the total number of trials. And then there are examples. Suppose you have 12 marbles. Without replacing any marbles, you pull a red 5 times. And then what is the experimental probability of getting a red marble the next time you pull? So we had 5 red marbles out of the 12 marbles. So probability of getting a red is going to be 5 out of 12. All right, so let's go ahead and take a look at some problems here. At softball practice, Manny had 6 hits out of 15 times at bat. What is the experimental probability that Manny will get a hit at his next time at bat? So this P here means probability of hit. So how many hits did Manny have? It says he had 6 hits. That goes in my numerator. How many times did he go to bat at the ball? Well, that's 15. And then again, simplified fraction and percent. So 6 and 15 are both equally divisible by 3. So 6 divided by 3 is 2, and 15 divided by 3 is 5. So 2/5 or 40% chance that Manny will get a hit based on what has happened. And then here it says, what is the experimental probability that Manny will not get a hit? So one way to do it is to take 1 and subtract the value that you had here, which would be our 2/5. 1 is the same as 5/5, 1 whole. 5 hits 5 times, and subtracting the 2 times that he actually did get hits tells us how many out of 5 were not hits, and that would be 3 out of 5. If it's easier, you could also just subtract to find out how many times he did not get a hit. So I could have done 15, and I could have subtracted 6 to get 9, And then I would have 9 out of 15 or 3 out of 5. That as a percent is going to be 60%. 3 divided by 5 times 100 gives me 60. All right, so let's take a look at a couple more problems. Go ahead and pause the video and try these 4 problems on your own. Okay, let's go ahead and check our answers. So here it says Pam is playing darts. She hits the bullseye 7 times out of 20 throws. What is the experimental probability that Pam will hit the bullseye on her next throw? So out of 20 throws, she got 7 times that she hit the bullseye. All right, so we have 7 out of 20. That's already in simplest form. 7 divided by 20 times 100 is going to give us 35%. Experimental probability that Pam will not hit the bullseye on her next throw. So we had 20 times she did it. We had 7 times that she hit bullseye, which means we had 13 times that she did not. So I have 13 out of 20, and that would give me 65%. Let's look at this next one. So far this year on Trisha's softball team has played 4 of their 20 games on field A. What is the experimental probability they will play their next game on field A? Well, 20 games total, that goes on the bottom part of my fraction. And then on the top, the 4 times that they played on field A. 4 and 20 are both evenly divisible by 4, so we're going to go ahead and divide by 4. And we get 1 out of 5, which is 20%. Okay, so if 4 out of 20 were on field A, we can subtract that to figure out how many times they played on field B. 16. So 16 out of 20, and again we can simplify that by dividing by 4. That tells us that 4/5 is the probability of playing on a field besides field A, and that's going to be 80%. All right, let's take a look at theoretical probability. So what is the probability of spinning a red? So theoretical is what we would expect to happen. So we start by counting up the sections. 1, 2, 3, 4, 5, 6, 7 equal sections. Okay, so theoretical probability of spinning a yellow is 1, 2 out of 7. For blue, this is really blue. It's kind of looking a little purplish here on the screen. But it's 1 out of 7. Red, we have 2 out of 7. And then green, we have 2 out of 7. All right. And then for experimental probability, that's, again, what actually happens. Theoretical is what we expect to happen. Experimental is what actually happens. So I'm going to move this a little bit here. Okay, let's see. 7 times. Okay, so we got green first. And then another green. We got red. Yellow. Red. Red. And yellow. Okay, so the experimental probability, we expected 2 out of 7 times for yellow, and that's what happened, 2 out of 7 times. Blue, we expected it once, we didn't get it at all. Red, we expected 2 out of 7 times, we got 3 out of 7. And then green, we expected 2 out of 7, and that is what happened. So theoretical is what we expect to happen. Experimental is based on what actually does happen. All right, let's do a little more work with theoretical probability. So theoretical probability of an event is found by comparing the number of ways an event can occur to the total number of equally likely outcomes. So we write it like a fraction, the number of ways the event can occur, and then the number of equally likely outcomes. So let's go ahead and take a look at the situation here. It says one of the games at a carnival is the wheel of letters. Find the probability that the wheel will stop on each letter. Write your answer as a decimal, fraction, decimal, and as a percent. Okay, so the first thing we need to do is count up our sections. So let's see, I'll start this first A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 equally likely sections. Okay, there is one section marked A. There's 1, 2, 3 sections marked B. There are 1, 2, 3, 4 sections marked C. And 1, 2 sections marked D. Okay, so now we're going to find the probability of each thing. Remember that P in parentheses means probability. So probability of spinning a B. There are 3 B's out of 10 sections. 3/10 as a decimal is that, 3/10, and as a percent is 30%. The probability of getting an A, there's 1 A out of 10 sections. 1 divided by 10 gives us 1/10, times 100 gives us 10%. Probability of getting a C, well, there's 4 out of 10. And then when we can simplify, because with fractions you always simplify if you can, we can divide by 2 over 2 to get 2/5. And that gives us 4/10 or 40%. Okay, and then probability of D. There are 2 sections marked D out of our 10 sections. That simplifies. To 1/5, 2/10, 20%. All right, go ahead and pause the video. Try this one on your own. Okay, let's check our answers. All right, there are 11 pennies and 9 dimes in the bag. When I add those together, that tells me that there are 20 coins. Find the probability of each event. Write your answer as a fraction, a decimal, and a percent. Okay, find the probability that a dime will be drawn from the bag. 9 dimes out of 20 coins. 9 divided by 20 gives us 45 hundredths. Move that decimal 2 places over or multiply by 100. We get 45%. Probability of a penny. We have 11 pennies out of 20 coins. 11 divided by 20 gives us 55 hundredths. Move that decimal 2 places over to the right, gives us 55%. All right. There are 6 yellow cards, 4 blue cards, and 10 green cards in a bag. A card is chosen at random. Find the probability of each event. Go ahead and pause the video. Try these on your own. Okay, let's check our answers. So first thing I need to do is figure out how many cards we have total. 6 plus 4 plus 10, that's going to give me 20. Okay, probability of yellow is 6 out of 20. Here we can divide by 2 over 2. That gives me 3 over 10, 30%. Remember, simplest form, fraction, and percent, unless it says something else. Okay, blue. I have 4 out of 20 for the blue. I can divide by 4 over 4. I'll get 1/5, which is 20%. For green, there are 10 green out of 20 cards. We can divide by 10 over 10. We get 1/2. Which is 50%. And then blue or green. So now we add them together. There are 4 blue, 10 green. So that's 14 that are either blue or green out of 20. Here we can divide by 2. Over 2 we get 7/10, which is 70%. All right, probability of independent and dependent events. Independent events are independent when the outcome of one event has no effect on the outcome of a second event. Rolling a number cube and flipping a coin are independent events. Find the probability of rolling a 4 and flipping heads. Okay, so we find the probability of each part separately. So probability of rolling a 4, well, that's going to be one outcome. So there are 6 different outcomes for our number cube. Hold on, let me just... Okay, sorry. I want to just skim ahead and see how they were doing it. 6 outcomes for the number cube, 2 outcomes for the coin. When we use a fundamental counting principle, that tells us there are 12 possible outcomes of rolling a number cube and flipping a coin. Here it says to make a list. So let's see, we can do 1 and heads. We could do 1 and tails. We could do 2 and heads, 2 and tails, 3 and heads, 3 and tails. We could do 4 and heads, 4 and tails, 5 and heads, 5 and tails, 6 heads, and 6 tails. Okay, so how many possible ways are there to roll a 4 and flip heads? Just 1. So our probability of 4 and heads would be 1 way out of 12 different options. So that's how you could get it with a list. You can also find the probability of each part and then multiply them together. So the probability of getting a 4 on a number cube is 1 out of 6. There's 1 4 out of the 6 options. And then for flipping heads, that's 1/2. And when we multiply those together, we get 1/12. And if we turn that into a percent, let's see, 1 divided by 12 gives me 8.3 repeating percent. All right. Events are dependent when the outcome of one event does have an effect on the outcome of the next event. Drawing 2 marbles in a row from a bag without replacing the first marble are dependent events. All right, so let's take a look at one of these problems. A bag contains 3 blue marbles and 5 red marbles. Find the probability of drawing 2 blue marbles in a row without replacing the first marble. Okay, so the total number of marbles in the bag, 8, 3 plus 5. Okay, and then there are, how many blue? 3 blues in the bag. So the probability of getting a blue on the first draw is 3/8. Once we take 1 out, there are now 7 marbles in the bag. And if we got what we wanted the first time, we have 2 marbles that are blue left. So on that second one, we have a 2 out of 7 chance. So to find the probability of both, we can multiply that together. We can do 3 out of 8 times 2 out of 7. If you multiply straight across, 3 times 2 is 6. 8 times 7 is 56. We can divide both of these by 2 to get 3 over 28. And then let's see what that would be as 8%. So we do 3 divided by 28, and we get, to the nearest tenth of a percent, 10.7% approximately. All right. Let's take a look at this one. The spinner shown is divided into 8 equal sections. Suppose you spin the pointer 40 times. How many times will you likely get a 3? All right, so we're going to find the probability for getting a 3 first. So we have 1 3 out of 8 sections. And then 40 times, so we're going to do the probability, 1/8, times the amount of trials, 40. Now, I know 1/8 times 40 means the same thing as 40 divided by 8. So my prediction would be that 5 times it would happen. How many times will you likely get a whole number greater than 0 and less than 9? Okay, so let's see. All of these numbers are greater than 0 and less than 9. So 8 out of 8, which is like 1 whole times 40. It's going to be 40. Explain our answer. Well, all of the numbers are, let's see, greater than 0 and less than 9. All right, let's take a look at this one. Suppose you took a marble from the bag without looking. After you took the marble, you look at it, you put it back in the bag. If you do this 50 times, how many times are you likely to pick a white marble? Go ahead and pause the video and try this one on your own. All right, let's see. We have 1 out of 5 marbles. And we're multiplying times 50 trials. 1/5 times 50 is the same thing as 50 divided by 5. That's going to be 10 times. All right, explain our answer. So, 1/5 of 50 is 10.